Hello. So, today we're going to be sketching this function. Well, this is a reciprocal function. They're the hardest type of function to sketch because they're very strange when you look at them, right? It's mainly because they have a thing called asymptotes. Asymptotes. They're very unique with reciprocal functions. There are two types of asymptotes, and then we'll just talk about them before we get into sketching this function. There are vertical asymptotes and horizontal asymptotes. Vertical asymptotes are the ones that are very unique with reciprocal functions. Vertical asymptotes are ones that you see when you break the rules of math. And because this is division, what specific division would break the rules of math? Dividing by 0, like 1 over 0. If something like that were to happen, it would just be, there would be this dashed line here, as the function would either approach infinity or negative infinity, because it can never reach 1 over 0. The other type of asymptote is horizontal. This one isn't unique to reciprocal functions, as other ones have it, like exponential and logarithmic. Horizontal asymptotes are ones that can be crossed, unlike vertical. They can be crossed, but once you get to extremely, extremely large values, it seems like it's going to approach this value when it clearly isn't. It is going to just like infinitely try and approach, but it's not. And it's horizontal most of the time. Sometimes horizontal asymptotes aren't even horizontal, then they're not considered horizontal asymptotes. Like slant asymptotes or oblique asymptotes, but we're not going to talk about that. So, that is the basic ground rules for the idea of a reciprocal function. So, let's try it out. So, our first step with usually sketching these is, let's find some vertical asymptotes. How do we find some vertical asymptotes? As I said, with reciprocals, it'd be something dividing by 0. So we must factor this out in order to make a better judgment about when this would divide by 0. So, let's put this over here. Minus 2x squared plus 8x minus 6 over x squared minus 4. Let's factor both the top and the bottom. You'll see why later. So, let's distribute the top, minus 2x squared minus 4 plus 3. I factored out the minus 2. Then the bottom, we're going to leave the same. So then now we have to factor this actually. So the way I'd factor this one out is by cross multiplication. 1 and 1 are factors of x squared. No, x and x are factors of x squared. Minus 3 and minus 1 are both factors of plus 3. When you cross multiply them, they add up to minus 4x. Okay, so thus we know the top one. And then that top one's going to be minus 2 times x minus 1 times x minus 3. Now the bottom, this one's a difference of squares. What that essentially means is it's a special type of factoring. Special type of formula, I guess. And then it's going to be x minus 2 and x plus 2. So, we got this factored equation. What do we do with it? Well, as everything, we were trying to find vertical asymptotes, right? We need to know when it divides by 0. So that means the denominator has to equal 0. So when does this equal to 0? It's like a classic solving a quadratic. It's going to be plus 2 and minus 2. So we got some vertical asymptotes. Let's draw them. Let's get a different marker, actually. It would be much better. Plus 2 and minus 2. Plus 2 and minus 2. These are the vertical asymptotes. Okay, so now let's not erase this because we still have one more thing we can do with this. What about the numerator? What can the numerator do? What if the numerator is 0? What would happen? If we divide anything, if 0 divided by anything equals 0, So that means if the numerator were 0, then we'd have an x-intercept. So what are the x-intercepts here? Well, this is another classic quadratic, solving this equation for 0. We get +1 and +3. We'll just dot these. +1, +3. So, now we don't have any more uses with this factored form, so let's erase it. So, now we have to find our horizontal asymptote. This one's a little trickier. Instead of factoring it out and just finding when the denominator equals 0, we have to use some intuition. So, what would happen as this value gets super duper large? Because we want to know what it approaches. But before we do that, let's see what happens when anything gets super duper large. Like x squared plus 2x plus 5. Okay? What would happen if this were to get super duper large? Well, one thing that would make a lot of sense is if we had like 1,000. I mean 100. Let's have 100. X squared would be 10,000. 2x would be 100. And then it'd be 5. This is, you can notice a pattern here, right? You can notice something. This value, x squared, is much larger than the other two. And as we get even bigger, let's do 10,000 now. So 10,000 would be this number with 8 zeros. What would it be? 100 million. Then our 2x would be 20,000. Then our 5 would be 5. So it looks like this value is getting much, much larger. So as we get super duper duper big, these other ones don't actually matter much, and we only care about the first one. So if you wanna make sense of why that would work, try and go on to Desmos, take this function, and also take this function. Zoom out as far as you possibly can, and then you'd notice that these two functions would essentially overlap as you get super duper big. But then remember, when it's super duper close, horizontal asymptotes can be crossed. But when it gets super duper big, it's not going to be crossed. So let's take advantage of this for this one. So the biggest power on the numerator is minus 2x squared. And the biggest power on the denominator is x squared. We care about both because if we care about one, then we just have a quadratic at this point. So we have to care about both the numerator and the denominator. So then when we factor this out, when we solve it, we get minus 2. So that is our horizontal asymptote, minus 2. So let's draw the horizontal asymptote with purple. It's minus 2. Okay. So now one more thing we can do before we actually solve this is find the y-intercept, which is pretty easy. We can just make x equal 0 and then we'll find the point. So that would be 3/2. So now we got all our points. So now the hard part is connecting all of them. So we can use these points to our advantage. These 3 points that I've drawn. You probably can't see them, but they're there. So we always know that with vertical asymptotes, we'll always start from either the top or the bottom. So because these 2 points are both above and we have to reach below, it wouldn't make much sense if we would go up like this, then go down. So I guess it'd make more sense we'd go like this. Ooh. You have to use some logical deduction here. Like, you can either go up or down. You try and think about how you connect those 2 points, and then make a logical conclusion. Like if you were to connect from the bottom, you'd have to go up and then down, which doesn't make much sense. So let's leave it like this. So then how do we find the other ones? Well, we know that if it were to come from above, this one, then over here, it must go down. That's the key. It would always go the opposite direction. Like if it were going down here, it would come from above again. As it passes that point, then it comes back. So then, as we're going down, we must come back up again, right? That makes sense. So we come from above, and woo. So we come from above it. So let's test this. If you're feeling very suspicious on your test that you somehow got this right, let's plot some points. Let's do one before the vertical asymptote at -2. Let's do -3. It's very dying marker. That's okay. So let's do -3. So if we substitute everything, we get -18, -24, -6 over 9 minus 5, which is 5, which is about, okay, so -42 minus 6 is -48 over 5, which is about -9. So where would that be? That's pretty close to -9. It's a little off, but this is a sketch, so it's okay. So I guess this is right. So let's try one after the other vertical asymptote. Let's do 3. We get -18 plus 24 minus 6 over 5, which would be 0. And then I realized this is actually the Y-intercept. This is the X-intercept, so I should pick a different point. So let's do 4. Well, 4, this would be -32 plus 32 minus 6 over 12. So this is my -6 over 12, which is -1/2. That makes sense because we have to go down to get to our horizontal asymptote. So I think we did it. We got it right. So, in a nutshell, this is how you do these functions. You first find your vertical asymptotes, your horizontal asymptotes, and some key points, and then connect the dots. And then if you do not trust yourself on the test paper, just plot some points. So, I hope you liked it, and goodbye.